my screen and just talk through some of the things that we've been releasing recently. So one of the latest releases for Argilla is what we did is we introduced this new kind of pip install thingy. And then whenever you've installed Argilla, what you can do now is actually directly deploy Argilla on spaces. So within the Python SDK, what you can do now is go to Argilla, then .deploy on spaces. Whenever you have your Hugging Face token configured or actually logged into the CLI, it will then use your Hugging Face token to duplicate the Argilla template space, and it will actually recreate that within a certain repo name. And along with that, what you can do is actually pass your Argilla API key, and this API key will then be used to authenticate to the deployed Argilla instance. So in the background, it will basically deploy Argilla for you, and you don't need to think about UI and all of these kind of things. It's really focused on the people that prefer to use code instead of other things. And then after that, you actually get this nice iframe showing Argilla, and you can also go to the official deployment here to kind of go outside of the iframe as well. So it's a nice addition that we've worked on. And what we recently released is this UI dataset import feature. So what we can do now is import datasets from the UI without needing any code and directly import them from Hugging Face. So whenever you would go to Argilla, you have your deployed Argilla instance, you can either go to this button to actually copy paste one of the dataset definitions that you can find on Hugging Face, one of these repo URLs. Just gonna mute someone. Yeah, perfect. So you can actually go to this overview and copy paste the dataset repo URL, and then directly go back to your Argilla instance, kind of load that dataset. You then get a representation of what your dataset is going to look like, and you can actually change that the way you want. So let's say that for this awesome ChatGPT prompts that we're not interested in the act, then we can actually remove that column from our dataset definition. And then we can actually say that we, for example, want to rate prompts based on a rating question. And maybe we also want to have an additional text question just to provide some context. And in that way, maybe we don't want a 7 rating, but a 10 scale rating. And in that way, we can actually create a dataset, call it awesome ChatGPT prompts, and create a dataset directly within the UI. So this is super useful for anyone that maybe works with developers, works with non-technical people or domain experts, and then people can actually start creating their own datasets. So at the moment, this is mostly for datasets that already exist on the hub. But the thing that you can also do is upload dataset to the hub in CSV. So what you can do is actually just go follow this guide. And within this guide, there's an overview of how you might upload a dataset as CSV files. And then anyone can initially upload the dataset here. And then after that, people would be able to directly import it to Argilla as well. So those are some cool new features that we've done. So I'm gonna start. Thank you all for coming today. For today, what we will go over is this token classification guidelines, or for how to set up a token classification project efficiently on the Hugging Face hub. There's some shortcuts that we'll go over. So there's more efficient frontier models that you can use for zero-shot classification for token classification, and there's also some more efficient training methods that we'll go over. So first, start with a brief overview in the form of some slides. So for token classification, there's these cool tools and frameworks that we'll use. Go over GliNER and NuExtract, NuNER, and Spanmarker. token classification basically takes like an arbitrary input text and then classifies the output as certain labels. This is like an overview of non-overlapping token classification, but you can also have like nested representations within like span annotations, and this also complicates the matter a lot. We do support that in Argilla, but for the sake of the example and simplicity, we'll just focus on this non-overlapping overview. So normally what you'll do whenever you start to think about like a problem or like an annotation task that you want to capture, you first try to model the problem. And this like matter cycle represents the way that you would actually go over such a process. And you start with modeling the problem. So really thinking about how do you want to represent your data, how do you want to represent your model. And that's in the case of Argilla, you start to think about how you define your annotation guidelines, how you set up the configuration for your data set, how many fields or input columns do you want to capture, how many questions or output annotations do people need to give. Then for the annotations, the second step, normally this is done by humans, but we actually allow for making this a lot more easier by initially using GliNER and NuExtract to give zero-shot model suggestions. So you would initially start with suggestions from a model and then annotate and correct them later on. So then the like train test and the evaluate step, we'll be using Spanmarker and GliNER, and Spanmarker is like an efficient few-shot training framework for NER, and it's produced by Tom Arsen during his internship at Argilla, and he's currently working as an engineer also at Hugging Face, working on sentence transformers and the set-fit package. And then finally, you kind of revise and evaluate the entire process, and that's also something that you do within Argilla, because then you use the trained model to once again kind of update all the predictions that you have, and then you end up with like the newly updated predictions, and then you kind of continue with modeling, revising the problem, once again annotating, training, testing, evaluating, and that's kind of the cycle that you normally go through when developing models. So it's like a continuous care and attention thing that you focus on. So GliNER is a zero-shot token classification model, and it works predictive, so not generative as all of the LLMs do nowadays. And normally what you do is you provide some text input, some labels, and a threshold. So this threshold you need to tweak in terms of the certainty that you allow for assigning the label, and whether you want to use nested and your, well, what I mentioned, like these overlapping spans, and if there might be spans within span classifications as well. And there's different versions of this model. So initially they released this V0 version, but then they kept on iterating and improving the model with, I guess, better data and better training. And nowadays there's these V2.1 versions of the models. And as you can see, the models are relatively small. So they're like maybe 0.2 billion or 200 million parameters. So this should be able to run fairly quickly compared to like several billion LLM doing generative tasks. An alternative to this for like using for zero-shot NER prediction might be the NuExtract model. And this is like an information extraction LLM, generative model. And normally what you pass is like a template, as you can see here on the left, like a JSON representation of the information that you want to capture. And then the model itself starts generating all of these entities that according to the model belong to the certain label within your template. So it's not really for NER. You can do like much prompt engineering because the model expects a specific prompt format, but it's like a way to actually abuse this information extraction optimized model to actually also use it for NER. And as you can see underneath, it seems to work quite nicely. One of the downsides is that this model is 4 billion parameters, and it's generative, so it's inherently slower. You might need a GPU or anything like that. Even though there's also a tiny model of 0.5 billion parameters, like 500 million available, and that you can run fairly okay on CPU together with Llama CPP. So that's like a way that you can actually use LLMs for NER as well. And the main differences are like the smaller versus larger model size. NuExtract doesn't necessarily support nested NER. For the GliNER, you actually need to fine-tune and tweak this threshold, this certainty predictor thing. So it might be a bit difficult to assess where you need to put this threshold. With GliNER, you can't really do prompt tuning, but with NuExtract, you can, because you can actually adapt the description in the labels better, and LLM should be able to capture that nuance better. And then the post-processing that you would require isn't really necessary for GliNER because it's a predictive model, but for NuExtract, you actually need to kind of convert the predicted text back to a JSON and then get the information from there. And on top of that, the GliNER model is really easy to fine-tune, and whenever fine-tuning an LLM, it becomes a lot more complex. And there's some token length considerations that you need to take into account. Due to the fact that this GliNER, NuExtract model is actually 128K token length model, but it's fine-tuned on top of Phi from Microsoft. So it's really long for these kind of tasks. But I'm not entirely sure if the NuExtract fine-tune of the model actually works with these long token lengths, because it hasn't been specifically tested for that. And then there's also this new NER model. Let's see, was there a question? No. Congrats. Okay. Then for the GliNER and NER model, this is like a foundation model specifically fine-tuned to work better with NER. And as you can see, for K is the training data, the samples of the training data within each class. You can actually see based compared to like a basic Roberta model for fine-tuning NER that the F1 really improves. So for initially like doubles with smaller amount of samples, and also with a bigger amount of samples per class, really improves a lot. And then there's a Spanmarker, and this is a specific approach to fine-tuning NER models. So this is implemented within the transformer library, so you don't need to think about all of these like configuration thingies. But basically it adds a start and an end marker along each of the tokens, and based on that, the model is able to distinguish better between actual spans and not spans. And this results in like state-of-the-art performance on fine-tunes in terms of F1 score, but also one of the more interesting things is that it actually performs way quicker in terms of fine-tuning. So if you look at the table underneath, then you can actually see that the training time when using Spanmarker compared to these other alternatives is twice as quick, more or less, which is super cool and really saves time and GPU costs as well. And then there's this like hobby package that we actually wrote, Tom and I together, where you kind of swap out different entities that you might have found for the entities of the same type. Like in this example data set, there's for example, Apple is looking to buy the United Kingdom startup for 1 billion euros. And when you actually know that, for example, there's multiple organizations or multiple locations or multiple entities of the same type, you might be able to synthetically augment your data, and you would kind of be able to generate different augmentations for your data set, resulting in more diverse training data. So this is the general overview. And whenever you would kind of get started with like a project, we have this overview that we have as a tutorial. So this is just a Google Colab notebook that you can actually use and copy. So in this example, we'll be showing a standard workflow for token classification. We'll just use this onto nodes dataset. For anyone that's unfamiliar, it's like this basic dataset that everyone uses for NER within educational settings. And within the dataset, there's some basic labels that represent like the law objects or organizational objects, percentage objects, money, works of art, time, persons, locations, and all of these more common labels that you might use for NER. But yeah, this tutorial can actually be adapted to anything you might want. On top of that, we'll be using like this NuExtract model. It's by NuMind, and this NuExtract model can easily be used with like this transformer package, but also with something like Llama CPP. And this is the generative LLM that you might use for information extraction. And as you can see, this is the specific prompt template that I mentioned before, where you define like the input tag, template, text, and the output. So this is something that you need to take into account when post-processing, that you actually have the right template, that you actually post-process the output in the correct way, and that you then just get the JSON representation that the model outputs in terms of the extracted relations. So this is, for example, a JSON template that you would pass along with the template above. And then lastly, there's also the GliNER model that we went over quickly. And this is something that you can directly just run without using an LLM. So you pass the text, the potential labels, and then the model predicts all of the entities there. And this can actually run on CPU fairly quickly. So for just showing the deployment of the Argilla server, so Argilla is basically a tool where you can kind of capture, store, and structure information for your data and actually iterate on a high quality data set. And that's also within the meta cycle that I showed before, the tool that we'll use for this. So when you want to get started with Argilla, you can either do that with like a SDK deployment as shown before, or you can do it with the no-code deployment, where you go to Hugging Face Spaces, then just select like a space name, Docker template, Argilla, and then select the free CPU upgrade, so to say, free CPU deployment, so you can actually deploy it for free. A thing that you need to take into account is that the hardware requirements by default don't support persistent storage. So when you actually want to keep your data safely and securely on the Hugging Face Hub, you actually need to ensure that you enable this persistent storage as well. And you can do that basically here. It costs one cent per hour, but you can also deploy Argilla with the Docker image anywhere else you want. Then when you've deployed Argilla, what you can do is just install all of the required packages. So in our case, it's Argilla, the GliNER package, transformers, Spanmarker, and the Hugging Face hub. Then what we can do is actually import all of the imports. And what I will do in this case is actually use one of these Argilla instances that I've created before. And that's in my example, the David Beerstein Argilla space, which has been deployed in the same way as shown before. So what we can do then is actually connect to this specific Argilla instance. And that's what we do through the API key. So the API key is something that you can see here, or that you can also get from your settings. Whenever you go there, you can just copy paste the API key and then use that as a specific code for authentication as well. Still installing a bit. Imports are done. So what we'll do then is actually use this client. A cool thing that you can also do now is within notebooks actually directly use the client and go into this iframe. You can kind of go into data sets that you might want to explore. So it's really easy whenever you created a data set to kind of directly start labeling within a notebook, or you can just go to the URL directly. In our example, we're going to use the onto nodes dataset. So it's always good to kind of think about what you want to capture in case of the dataset. In our case, we'll be working with tokens and tags, and these tags actually represent these entity types. So that's something that we need to consider when actually working with NER data, that we need to convert it to the right format. And it's something that we need to take into account. So in this case, we'll start with thinking about what we want to capture and how to configure our Argilla dataset. We'll start off with all of the labels that we found within the original dataset definition. And then what we do at Argilla is come up with this settings configuration. In this case, we'll define like some basic annotation guidelines. You might like add some information about each one of these labels for your annotators to understand what they should represent. You might be able to add some prime examples or these kind of things. And then on top of that, you define some input fields, which in this case are going to be like the input text, and then some output questions that you would expect. So in this case, it's the span label questions. And we'll be adding some title about what this question represents, and will not include overlapping classifications because of what I mentioned earlier, that we don't want to include that. Then whenever you have your data sets, you can actually, settings, you can actually create a new data set from that. So this would be the token classification dataset new. Settings are going to be the settings that we just defined, and then we will create the dataset. So in this case, we'll just be creating the dataset, and you'll see like some basic information about the update time, the number of submitted records, and these kind of things. One thing to notice is that you can also define this task distribution, where in this case, we'll expect that each one of the annotators that gets like a record or data entry should submit one response. You can also choose to do 2 or 3 responses if you want your annotators to align and to have a better source of truth, but normally you can just leave it to 1. So in this case, we can go back to the Argilla instance, and we see that this like overview has been created. There's no record yet, but we can see like all of the labels that are present. We can see maybe some of the guidelines. And that looks quite nicely as in terms of UI. Now we'll go on and add some records. So we have this data set that we will upload, the TNAR onto nodes data set, and we'll just use the first 2100 examples from the test version of this data set. We'll then actually use this data set to create some records. So we'll join the tokens and add a space in between for each one of these rows, because as you might have remembered, they are as a list, represent as a list of individual tokens, like we see here. So after joining them, we'll actually add them to the field representation for each one of these records, and then log the records into Argilla. So in this case, these records are going to be added. We have like this updated definition of the dataset, and we can go back to Argilla and maybe refresh the page, and then we actually see that these records are available here. So what we could do normally, whenever you start a project like this, you can start like annotating apparently subject program that might be like or Western technology, like NORP, because that's like a representation. So software might be a NORP, Western might be NORP as well. And then you go through everything one by one by hand. But as you can imagine, this takes a lot of time. You don't know where to look. This is like quite straining for your annotators. So what we can do is kind of do some work for them and think about how to make it easier for them to actually get started. And that's what we'll do by adding these initial model suggestions with NuExtract, or with the GliNER zero-shot classification thing. So next we'll be adding these model suggestions. In this case, we'll just use the GliNER model, but in the meantime, I'll also kind of walk you through how you might do this with an LLM instead. So in this case, we'll be using Llama CPP, and Llama CPP is a package that you can download, and it can actually run like LLMs on CPP, C++, instead of using pure Python. So it's a lot quicker, and by doing this, you can actually run like fairly sized, like smaller size models fairly well on CPU as well. So in this case, we'll be using this llama model. In this case, it's the GGUF representation of the model. And this is like a file format that you can load into llama CPP, and it's optimized for running and running quantized LLMs. In this case, what we will also do is import this JSON thing, because as you might have remembered, we actually want this specific format. So what we have is a predict function that takes an LLM, so the initialized model, some arbitrary text, and it's like the written text that you want entities to extract from, the entity labels, batch size, max length, and some of these things. In this case, the entities are going to be, like, for the sake of the example, person, book, location, date, actor, and character, and there's this like arbitrary text that you have here. We'll then pass, like, format the prompt based on all of this information. We'll then create prompts for each one of the texts, and then just loop through each one of these prompts and actually end up with getting the generated text split by the output thing, and then load the output into a JSON representation, because this specific model is trained to output these JSON extracted JSON information. And then based on this actually running on CPU, so not like a fancy GPU, not even from Colab Pro. And if everything goes well, then it should run fairly quick too. The nice thing about this approach is that you can also kind of fine-tune the labels a little bit. So, for example, let's say we don't want to get a normal actor, but we want to represent maybe like female actor or male actor slightly differently, then we might be able to do something like this. And what we can see here is the extracted information. So I also did some formatting in terms of finding the entities in the text, etc. And then you can actually see that there's like person, the text that was found, the start character, and the end character. And we actually did that for each one of these entities. And what happens if we actually run it, for example, with a female actor and male actor, we can actually see if the model is able to distinguish properly between these. But as you will see in a bit, it actually works quite well. So that might be possible for these labels, but you can actually provide any random label that you come up with, or any random description of information that you want to extract from your original text. So this is kind of promptable in a way by defining the labels a bit more specifically. And this is one of the things that's not supported by GliNER, but the other model for predictive tasks out of the box. But this model generally, the GliNER model generally performs better on any art task and is fine-tunable. So you can also swap them out for your specific use case. And as you can see here, the model did some made some guesstimates about whether actor name is male or female. Then we download the GliNER model, so the predictive model that's really optimized for zero-shot NER. In this case, we actually are using a GPU because of the example. And then what we can do next is define this prediction function. So this prediction function actually gets the entities from a text based on the labels and based on this tweakable threshold that I mentioned before. So this threshold is kind of a certainty score that the model outputs as well. And based on the certainty score, you can actually choose to include or exclude entities from the predictive set. And this is something that you would need to kind of play around with, iterate a bit, maybe start with a higher threshold score, see if it makes sense and the output makes sense, and then maybe go lower and lower because of the potential bias and then the wrong predictions that you might include. Then when when defining this function, you will actually output them as like a nice dictionary representation. In this case, what we'll do is get a list of all of the records. But for the sake of the example, we'll just get like the first 10 records. Then we'll convert like each one of these records into model suggestions. So for each one of the records in the set that we get, we'll pass the GliNER model the sample text and the potential labels that we've defined along with a threshold to the predict function, and this outputs the span predictions for that based on the score and the text. After that, we will actually loop through all of the records and the suggestions, and then we will be adding these suggestions to the record, and we'll be then updating the records within Argilla. So in this case, what we would end up with, if we would run that on the entire data set, is like this data set with a lot of suggestions for everything. And this data set we can then directly use to make predictions on, but to make annotations a bit more easier. So in this case, the predictions are all for persons. I'm not sure why that happened. Let me see. Maybe I should have used this one. So normally you end up with, let's see if the predictions are here somewhere. Updated. Yeah, so you would end up with these initial model suggestions. And as you can see, this initial suggestions already work quite well. So you have some money predictions, some percentage predictions, date predictions, quantity predictions. And this, is just by running this model against your initial data set, not really thinking about anything in particular, but this really allows the annotator to go through all of the records and all of the data way more efficiently. So in this case, these are mere predictions. And normally what you would do when actually going over all of these records one by one is then just confirming the record instead of actually selecting everything manually and then selecting the label, then selecting this. So it goes a lot quicker for each one of the annotators. Then whenever you submit a record, this submission is not changed anymore. And you can actually use it for as a validated record and actually use it for fine-tuning a model. So whenever you kind of go into the suggestions, this is what it kind of looks like. So this is span label, the value, and then the start and end character and the label that's attached to the suggestion. So this is actually nicely represented in the UI. We can then also open the UI here to maybe annotate some examples. But for now, let's go to the model training. So whenever you want to start training your model, you actually need to load your data set. In this case, we are working with the token classification dataset new. So this is just for the sake of the example. We have 2 submitted records that we'll use as training data, but normally you would still need to kind of go over all of the records and kind of iterate and validate whether the records are correct. So in this case, we can load the token classification dataset. We can apply this query filter to the dataset. So in this case, we'll check if the response status equals submitted. So in this case, we'll just filter and take all of the submitted records. Then we'll convert the records to an IOB format. This is a specific format that the Transformers library expects whenever you work on fine-tuning token classification models. It is a bit unintuitive and takes some time for getting used to, but if you want to know how this works, you can actually go into some of the Hugging Face or the Transformers documentation to get a bit more familiar with it. But basically it is it indicates where spans start, where spans are continuing, and where spans end by adding these by B and I tags. But there's different representations as well. And this is something that will run on top of our data set to actually format each one of the records accordingly. Then on top of that, we'll be adding some labels and some ID to label representations as well, and also a mapping for each one of the tags to the corresponding label. So that's kind of similar to the representation that you saw before, like here. So O is 0, B1 is 1, etc. And this is just something that Transformers expects when fine-tuning a model. Then for each one of the records, we'll be getting the tokens and then the obtained NER tags. based on the transformation that we just provided. And what we can then do is get the data set from a list of records and apply a train test split. So in this case, we'll just do a 50-50 split because we only have one record. Then we'll check if CUDA is available and if we can actually get the device from Torch in case of Google Colab. But whenever you use like a MacBook Pro or anything, you can also check for MPS and use MPS as a like Apple Silicon for training and speeding up the training pipeline. Then in this case, we'll be using the NuNER model, and this is the foundation model that's really optimized for fine-tuning NER. And on top of that, we'll be using this Spanmarker framework that I introduced before. So we'll just get the encoder ID, we'll get the model loaded, and then along with that, we'll actually define some training arguments. So this is like some default learning rates and these kind of things. There's some ways to optimize this, but this is really the last step if you want to squeeze the final efficiency out of your data and out of your model. Then you can look at optimizing training arguments. But before that, it's really important to think about your problem statement, think about your data, think about all of these things that are more fundamental to the problem. And then after you can like work on training arguments. And then on top of that, we'll pass like the trainer, the arguments, and train and test data sets. So we'll be loading this like NuNER model. And then what we can actually do is start the training process. This is probably going to be done in a second, but whenever you have like a bigger data set, the training will last a lot longer. In this case, you can actually offload your training script to 1 dB weights and biases. And what you can do is just as shown here, I guess. Just go to 1db.ai, and then you can authorize like your 1db account. In this case, I will just use my account, and then you can actually see some plots of the evaluation and training curves as well. And then you would pass your 1db ID. In this case, we'll just do enter. Oh, it doesn't work. So let's get my API key. Authentication. Books reveal. So we can get my API key, and then the training will actually be offloaded to 1db, and you can actually see like the project, you can see the specific run within the project, and this is also one of these steps that you would do whenever you're optimizing for like the training arguments. Then after that, you can actually just call the evaluate method. In this case, the accuracy is probably not going to be that high because we didn't really train. And then after that, you can like save your pre-trained model to disk or actually upload it somewhere to the Hugging Face Hub to not lose your predicted model. After that, what you can do is you can actually create these new predictions with the Spanmarker model. And whenever you have like your model available, you assume that the model has improved and has in fact learned to represent your data better than your initial model, like GliNER or like the zero-shot models that we mentioned, GliNER or NuExtract. And then you can actually create this predict function for Spanmarker. You can then loop again through each one of your records to update the initial predictions that you've done. And then based on that, the annotation process should continue. And normally this model would kind of go into production somewhere. And it's always the best thing to actually log some of the data with some of the predictions back to Argilla, because then you would be able to kind of keep track of how well the model is performing in practice, if it's aligned with what your annotators think that's correct. Because whenever your annotators would add annotations on top of the model predictions that don't align with them, you can actually get some accuracy and F1 scores for the model against your annotators. And this is kind of the overview of how you would go from an like initial idea or project idea for NER or token classification to actually fine tuning and then working with a model. I'm not sure if there's questions or anyone has an idea about like a project that they would like to work on and would like to discuss. There's one question. So to be clear, you're using Argilla on Hugging Face for annotation and use 2 models, and you use Spanmarker to fine tune the NuExtract model. Yeah. So what we did is we initially had we initially deployed Argilla on Hugging Face for free. So that's correct. You use Hugging Face or you use Argilla for annotation. And you can use either of the 2 models, either GliNER or NuExtract, for adding initial model suggestions. These model suggestions then get represented within Argilla as like initial suggestions for your annotators that you should later on correct. And then after you have your corrected and high quality data set, you can then use Spanmarker to fine tune the new NER model, so like a BERT model, so to say, which is like the state-of-the-art model for fine-tuning with NER. And how would you test the results of the model and ensure consistency? So the results of the model, normally, like the thing I mentioned is that whenever you have your model done after training, you already have your evaluation from the training overview. So you would already kind of know what the initial performance is of the model. But whenever you deploy your model, what you can also do is keep on logging your data back to Argilla, maybe in another data set or within the same data set. And then based on that data set, you would then continuously need to evaluate whether or annotate the predictions of the model and see if they are aligned with your initial model. And this should also take into account for data drift, data shift, and all of these things that maybe the data that your model is getting might be slightly changing, or like some expectations that you have on labels might be changing. And that's like an iterative process. You could offload that partially to LLMs, but also when you use LLMs like NuExtract, you should still kind of need some human evaluation, because yeah, otherwise nobody would be checking the output of LLMs. And that's how you kind of test the results for consistency. So it's really an iterative process that takes a lot of effort and care, but with the Argilla UI, it's supposedly easier to do that, along with like some other annotation tools that you might find out there. But we believe that our approach is the smoothest. What's your take on using LLMs for entity tree extraction in general for the biomedical domain when the number of labels is around 20? So I think specifically for niche domains, you would expect that your LLM is kind of trained on these domains and is able to capture the essence and the nuance of each one of these labels. And that's generally something that that LLMs have less well represented training data for. And that's also why fine-tuning for like something like a new NER model, like just a BERT transformer model, predictive model, is a lot easier to do and a lot more controllable than fine-tuning an LLM. And that's generally one of these scenarios where I would expect or advise just using a specific BERT model, a predictive model. Argilla is completely free to use, even for commercial use. Can you clarify that? Yeah, so Argilla is free to use. You can deploy it however you want. I chose the 0.01 cent per hour deployment because that's in order to actually ensure that there's like persistent storage. So you can use Argilla, but on the Hugging Face Hub for free. but after 48 hours of inactivity, your data gets, or the instance gets rebooted, just to not have a lot of stale instances that are not being used. And then you actually lose your data if it's stored in there. So that's whenever you would gonna choose to include persistent storage for 0.1 cent a dollar, per hour, then you actually have persistent storage enabled and you won't lose your data. What you could do is also in between just store your data on the hub, like as a hub data set, because there's like these push and pull to hub features. And on top of that, what you can also do is just deploy it locally, deploy it on your own cloud, and handle the persistent storage yourself. So these are different ways that you can actually use Argilla, but it's completely free and it's under through the open source license, so you can do with it whatever you want. How do you handle duplicates in text when finding start and end indices? So normally what we recommend is if something is unclear or there's duplicates or overlapping spans, it might not make sense, just avoid the specific record, because normally you would want your data to represent like a very certain data set, a very high quality data set. And if these duplicates or uncertainties within your data aren't even clear for your annotators, then it's probably better just to leave them out, because if your annotators are not going to be able to make the distinguishment between them, then probably the model is not going to be able to do that either, even though it's has a very high accuracy. But because then in the end, the model itself is also picking up on these duplicates and uncertainties. Then we're going to do exactly that for fine-tuning PubMed BERT for token classification. But relationship extraction with LLM seemed to be more promising. Yes, so that's a thing. Relationship extraction for LLM seems to be more promising. NuExtract is very good at that. There's also the specific zero-shot relationship extraction models. Relationship extraction available on the hub, and this is kind of the same story, that you can fine-tune a relationship extraction model that's predictive a bit more easier than you would do with like a Hugging Face with LLMs. Let me check. But yeah, if you Google zero-shot relationship extraction models on Hugging Face Hub, you'll be able to find it. I think it's this one, Furel. I will share it. So this is like the Furel zero-shot model, and it works in the same way, so to say. So you would be able to fine-tune this maybe a bit more easier than a NuExtract model. But once again, the LLMs are really good at relationship extraction. Also, a thing that I've done before is you initially use like divide and conquer the problem. Initially use an entity recognition model or something like that to identify the entities, and then pass these entities along with the prompt for your LLM. And then your LLM should be able to be more directed towards finding relationships for these specific entities when prompted correctly. And then you kind of simplify the problem, because you already provide some additional information to the LLM where it cannot make mistakes, or make less mistakes, so to say. Are these models also good in multilingual test cases? Yeah, so for a NuExtract specifically, I think it's based on the Phi model by Microsoft. So that model is actually trained on multilingual data, so it should be able to capture some of the nuances in different languages as well. But it's also not specifically optimized for that. And for the new NER model, for predictive examples, or for any other BERT model, you can just choose a multilingual model as well. So for NuNER, there's actually versions of the model that are specifically multilingual. I will share that too. So for example, this NuNER, specifically multilingual v0.1, so you would be able to use that. For model, would you use for static regression? What do you mean for static regression? In what context? Okay, maybe I'm gonna skip that question then. I'm not sure if there's other questions about like NLP or NER. Okay, cool. Yeah, happy. Let me know how it goes, and would love to hear some feedback about the outcomes. And also, if there's like questions on how to approach this or how to actually get started, how to deploy Argilla, there's the Hugging Face Discord always available. So you can actually go to the Hugging Face Discord. You can contact me on LinkedIn or whatever, and actually use that as well to help get some additional help to get started. Are there any more questions? Because otherwise, then I'm gonna say goodbye and hope to see you during one of the follow-up meetups. I guess we'll be doing one again in a couple of weeks, like 2-3 weeks, hopefully focusing on either benchmarking or RAG in the context of Argilla and Hugging Face and how to actually get started efficiently with that. There's like a notebook about synthetic data generation that I've also been wanting to share. So we'll kind of go over some of these topics. If you have any suggestions or proposals, feel free to contact me as well. And hope to see you for the follow-up meeting. Bye-bye.